I'm going to combine sections 2.2 and 2.3 into one set of notes. They will have one set of homework. The section is called Introduction to Sets. Sets are any collection of objects, and elements are the individual objects in a set. Sometimes these are also called members. A few generalizations. All sets are named with capital letters. Elements are listed inside a pair of braces. I often call them curly braces. The order of the elements does not matter. So 1, 2, 3 would be the same as 3, 2, 1. That's set. And each element can only be listed once. So you won't have the same thing listed twice in a set. So the first thing we're going to look at is set notation. So we're going to write the following set in set notation. The set A is lowercase letters in the alphabet. So capital A, curly braces, A, B, C, and you could list them all. I'm going to use the dots in the middle to represent that it's every letter in between. And so then we'd have all of the letters in the alphabet that are lowercase. And so then the number of elements would be 26 elements because there are 26 letters in the alphabet. The element symbol kind of looks like an E. It means a particular object is an element of the set. So lowercase m would be an element of set A. But uppercase M would not be an element of A. So we can write it with a line through it, meaning not an element. There are two common ways that we can write sets. First one is the listing or roster method, which is what we used with the alphabet. Okay, and so an example of that is, let's say we have set C, and it's just the numbers 1, 2, 3, 4. The set builder notation is another way of writing a set, and I'm going to write out one of them. So set F is set, and it looks a little bit different. You put X, then a vertical bar, which stands for such that, and then a lot of times you have a formula right here. X equals 2n minus 1, where n is an element of capital N. Now, we haven't talked about this yet. Capital N is the natural numbers, which are our counting numbers. So when you have one of these, what you're going to do is you're going to actually find the listing method for this. And the way you do that is just like finding a sequence like we did in the last section. Okay, so 2n minus 1 is the formula to find the sequence. The n is the counting numbers, 1, 2, 3, 4. So we plug in 1. So 2 times 1 minus 1 is 1, the first. Then we plug in 2. 2 times 2 minus 1 is 3. That's to get the second. To get the third, 2 times 3 minus 1 is 5. Fourth, 2 times 4 minus 1 is 7. And here you should start seeing a pattern that these are the odd numbers. So if you're given one like this, you're going to want to write it out in the listing method so that you could see the actual numbers. The next thing is the cardinal number of set, and all that is the number of elements in the set. So when we talked about the set with the alphabet, we said there are 26 elements, so the cardinal number would be 26. Okay, so looking at the first one here, find the cardinal number of set B, which is 1, 4, 6, 9, and 12. This is a set that shows all of its elements. So I'm going to use this up here, just like it has up here. That's the number of elements in B. And here we could just count them off. So 1, 2, 3, 4, 5. The next one, the cardinal number of set C, 4, 5, 6, 7, all the way up to 205. Here we're going to use a method that we used in the very first section, where we can do last number minus first number plus 1. Remember, we did that with Gauss's method to try and figure out how many columns we would end up with. So 205 minus 4 plus 1 gives us 202. Okay, the next one, find the cardinal number of the empty set. Now, I haven't talked about the empty set yet, but it's exactly what it sounds like. It's a set that is empty. And there are two ways to write it. You can either write it as a set of curly braces that have nothing in it, or the one I like the most is a 0 with a slash through it. Now this right here, putting them together, is incorrect, okay, because that's the set of the empty set, which is not completely empty. All right, so then the number of elements in the empty set would be 0. Now, an infinite set is a set where we cannot count how many elements there are. So a couple of examples are the natural numbers, which I talked about just a minute ago. Those are our counting numbers. Okay, they go on forever. Another example would be our whole numbers. Okay, and whole numbers are just like the counting numbers, except that they include 0 also. And the last example I'll give you is integers. And integers are all positive and negative counting numbers and zeros. So we write it like this, dot, 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 -3, -2, -1, 0, 1, 2, 3, goes on forever in both directions. Okay, moving on. We're going to talk about the intersection of two sets. The intersection of two sets is written like this, and that's the set of all elements that are in common both sets. Okay, a lot of times you'll also hear the word and. What's an A and B? And so this is what they have in common. Okay, so on this first one, A intersects B. Well, we have the numbers 1, 2, 3, 4, and B is 3, 4, 5, 6. So what they have in common is 3 and 4. So A intersect B would be 3, 4. On this next one, A is 0, 2, 4, 6, so it's 0 in the even numbers. B is the odd numbers. These have nothing in common, so that's the empty set. On this last one, A is 2, 4, 6, 8, the even numbers. And B is 1, 2, 3, 4, it looks like the counting numbers. So what they have in common, and if we kept going, would be the even numbers. So 2, 4, 6, 8, and so on. Now, another way we could say the same answer is the answer we got ended up equaling one of the sets we already had. So we could say it's also equal to A. Okay, the next one, the union of two sets. kind of looks like a U. Okay, and then that's all the sets that are in both of them. So on this one, we're going to end up putting the two sets together. And the word that's common used here is the word or. Is it an A or B? Okay, so we're going to do the union of the problems that we were talking about up here. So part A union B. Okay, well that means we're going to have all of A, 1, 2, 3, 4, and then include everything that's also in B. We've already have 3 and 4. Remember, you don't list it twice. 5 and 6. Part B, A union B. Okay, we have 0, 2, 4, 6, and then we had 1, 3, 5, 7. You can start with the evens, but it's nice to put them together and put them in order so you only have one set of dots. In fact, I don't think my math lab will take 2 sets of dots. Okay, so you'd have 0, 1, 2, 3, and so on. Okay, and now if you remember, this was also the whole number, so you could also put that this is W. I will take 0, 1, 2, 3. That is perfectly fine. Then part C, A union B. Okay, if I start looking at 2, 4, 6, 8, remember those are also in B. So it ends up being 1, 2, 3, 4, and so on. 2 other ways we could list this answer is 1, 2, 3, 4 happens to also be set B. It also happens to be our counting numbers. So all of those would work. The next one is the complement of A with respect to B, relative to B. This is also called the set difference. And we can write it as B minus A. And that's pretty much what you're doing. You're taking all the sets in B, all the elements in B, and taking away the ones that are also in A. So if we let A equal the letters D, E, F, B is A, B, C, D, E, F, and C is A, B, C, we're going to find these set differences. So I always feel the easiest way is write out the first set. So I have A, B, C, D, E, F for set B. I'm going to take away the things that are in A. I'm going to take away D, A, and F. So it leaves me with A, B, and C, which also happens to be set C. Again, either one of these answers will be fine. Doing the same with B minus C. Again, write out B. And then say C is A, B, and C. So I'm left with D, E, F. So you could either leave D, E, F as your answer, or you could also say it's A. Okay, the last one, A minus B. So you write out A this time. And then we look at B, and we start taking away what's in B. Well, we have A, B, C, but those aren't in there. We don't need to worry about that. We only need to worry about the ones that are in there. So D, E, and F. That means we took away everything in there, so then our answer is the empty set. The next thing we're going to say, a universal set is a set contains all elements being considered in a problem. So like if we were talking about the population in Houston, the universal set would be the population in Houston. Venn diagram is a diagram that represents sets within a triangle. Rectangle. The rectangle represents the universal set, and the circles inside represent other sets that are part of it. So if we were talking about the population in Houston, We could have circles that were the females in Houston or males in Houston. And if those two circles overlap, then it means they have something in common. Okay, so what we're going to do with this is we're going to color in these Venn diagrams here. Okay, and so we got to remember our definitions. Okay, so A intersect B. Remember the word and it was where they overlap, but they have in common. So A intersect B will be represented by just that area where they overlap. For A union B, the word or is it an A or B? And here's where we put the sets together. So it'll be all of A and all of B. And the last one, the set difference, you take all of the set B and take away what's in set A. So all of set B would just be entire circle. We take away what's in set A, it ends up being right here. Okay, so let's look at some applications of this. Okay, we're going to use Venn diagrams as a problem-solving tool. So in this Venn diagram, M is the number of students taking a math class, and E is the number of students taking an English class. We're going to identify in words and in set notation what each area is representing. Okay, so let's see. Just write it all these out real quick. All right, so probably the easiest one to start with is B, where they overlap. And this would be taking math and English. Okay, so we've got the word and, it's where they overlap. So it'll be math intersect E. Okay, so then looking at A, that's going to be taking math but not English. Okay? Okay, so that's this little moon right here. Okay, and a way to represent that is you could take the whole math circle and take away what's in English. Okay, C is the opposite, taking English but not math. Okay, so we could say it's the whole English circle minus the math circle. Okay, and then part D is the outside, so that would be people not taking either one. Okay, and there's a couple of ways to represent this, but one way is you could say, I have math union English. Okay, so that would be the two circles, and I'm going to take it away from the universal set. Yeah, working with Venn diagrams and getting some answers out of them. So here it's telling us the number of elements in A is 20, the total number of elements in B is 23, and in their intersection is 12. We want to know how many are in their union. Okay, so we're going to draw a picture out of this. Okay, and when you draw a Venn diagram, you're going to write in numbers that represent how many elements. Always start with the middle of your Venn diagrams. The middle of the Venn diagram on this one would be where the two overlap. Okay, so that would be right here. So we're going to start in the middle of the Venn diagram. Okay, so that would represent a 12 here in the middle. Then work backwards. Okay, so I'm going to look at B here. And in B, we have a total of 23 elements. But in our Venn diagram, we already used 12 up in the middle. So I'm going to subtract that out. So 23 minus 12 will give me 11. So that means I have 11 elements in B. Now, if we look at our circle and we add those up, 12 plus 11 gives us 23, our total. In A, we have a total of 20, but we used up 12 for the middle, so I'm left with 8. So now, to find the number in their union, we need to add these numbers up. So 8 plus 12 plus 11. And that gives me 31. So in their union, we have 31. Okay, the next example uses 3 circles in our Venn diagram because we have 3 different things we're talking about. You're going to end up having a project that looks very similar to this later on. So what we need to do is first we're going to draw our Venn diagram. So we have 110 college freshmen show that they took the following classes during their senior year of high school. 25 took biology, 25 took physics, 45 took biology, 48 took math. And then we have combinations. 10 took physics and math, 8 took biology and math, 6 took physics and biology, 5 took all 3. Okay, so I'm going to start my Venn diagram. When you have 3 circles, your first 2 look like how they looked in the previous problem, and then we add a third circle down here. So I'm going to label this P, B, and M for physics, biology, and math. Okay, and so just like we did in the previous example, you're going to start in the very middle of your Venn diagram, which happens to be where all 3 of them overlap. Okay, and your list here is 5 took all 3 is right here. So I'm going to put a 5 in the middle. Okay, now we're going to have some subtractions. Okay, because we've already used up 5. So let's take a look. But I like to just work my way up the list this way. So 6 took physics and biology. Okay, so physics and biology are these 2 circles. They overlap in these 2 areas. I already used up 5 down here. This could be 6 minus 5 is left. So that'll be a 1. Next, 8 took biology and math. So biology and math right here. They overlap in these 2 areas. I've already used up 5. So 8 minus 5. 8 minus 5 is 3. Keep moving up. 10 took physics and math. Physics and math is right here. They overlap in these 2 areas. So we go 10 minus 5. Leaves us with 5. Okay, now we have whole circles. 48 took math. So I have 48 taking math. So this whole circle needs to add up to 48. I've already used 13. So this will go 48 minus 13. And that gives me 35. Keep moving up. Biology circle should add up to 45. Let's see, we've already used up 9. So I'm going to go 45 minus 9 is 36. And then the last one, the physics circle should add up to 25. We've already used 11, so 25 minus 11 gives us 14. Now we're not quite done. In the previous one we were done because that's all the information we have. We still need to figure out one more number. We know there's 110 college freshmen. So what we need to do is figure out how many students we've used so far. Okay, and so the way to do that is we're going to add up all those numbers. 14 plus 1, 36, plus 5, plus 5, plus 3, plus 35 equals 99. Okay, so we've only used 99 of the 110 students, so 110 minus 99 gives me 11, so that means 11 students weren't taking any of these. Okay, so now let's answer these questions. How many students only took math? That means that the area that it doesn't overlap with anything else. So here's the math circle. The only place it doesn't overlap with any of the others is down here. So that one will be 35. The next one, how many students took biology and physics? And part C, how many students took biology or physics? These are very, very similar. And is where they overlap. Or, remember, meant put together. Okay, so biology and physics. That's these two circles. They overlap here. 5 and 1 give me 6. Now for biology or physics, we're going to end up adding all of these numbers together. So you go 14 plus 1 plus 36 plus 5 plus 5 plus 3. Let's see. I'm adding them up real quick. I didn't have this one ready. 64. Next one, how many students took biology but neither math nor physics? Okay, this question is saying biology, so biology is right here, but take away the math and the physics. Well, that's the same thing as asking for biology only. Just another way of asking the same question. So biology only would be 36. The next one, how many took physics, biology, or math? Again, remember, or means put together. So then we're putting all of those circles together, which remember over here we did that and we got 99. And then how many did not take any of these? Remember that was this number right here is 11. Okay, that concludes the notes for this section. I encourage you to pause it so that you can try the worksheet on your own. Okay. So let's take a look at this worksheet. And so the first one, we've got to find the cardinal number of these groups. And so the first one has 8, 9, 10, all the way up to 157. So we're going to do 157, the biggest, minus smallest, plus 1. I'm putting this in my calculator real quick, just to double check myself. And I get 150. The next one, 246 up to 242, this one is all the even numbers. So I'm going to take all the even numbers up to 242. So I'm going to take the biggest and divide it by 2 and give me 121. So we're only using 121 numbers there. Okay, the next one, A union B, remember, is putting A and B together. So A is 2, 4, 6, 8, and B is 2, 3, 4. So to put those together and put them in order, I'd have 2, 3, 4, 6, 8. 2, 3, 4 came from B. I already had 2 and 4, 6 and 8. B intersects C, and remember that's what they have in common. So B is 2, 3, 4. C is 1, 3, 5, 7. So 2, 3, 4, 1, 3, 5, 7. The only thing they have in common is the number 3. A intersects C. What do A and C have in common? Let's see. A is 2, 4, 6, 8, and C is 1, 3, 5, 7. So those are all even. Those are all odd. They're not going to have anything in common. Now a set difference. Take everything in A and take away what's in B. So I'm going to take away a 2. There's no 3 to take away, but I can take away a 4. And so then my answer ends up being 6 and 8. The next example is very similar to the project you're going to get. You're going to collect some data, and there will be more information on that very soon. And I will send out an email about that too. But when I have this class face-to-face, I have people raise their hand. So first, I'm going to do some data from a class I already had. There are 18 students in that class, and I just had them raise their hand. I said, who has a dog at home? Who has a cat at home? Who has a fish? And so on. So the numbers I got is 13 had a dog, 3 had a cat, and 2 had a fish. And then the combinations, if they overlapped over here, they still rose their hand for dog and for cat, but then the dog and cat people were 3, the dog and fish people were 2, cat and fish was 1, and people who had all 3 was 1. Okay, so then we're going to set up a Venn diagram exactly the same way that we set it up in the notes. Move this down a little bit so we have plenty of room. Okay, and so just like we did there, we're going to work backwards. So we're going to start with all 3. One person had all 3. Cat and fish, right here, overlap here. We only have 1. Well, we already used that 1 here, so that means there's none left over. Dog and fish overlap here. It needs to add up to 2. I already used 1, so I need 1 more. Dog and cat is 3. So dog and cat goes across the top. It's these 2, 1, and then 2 more. Then fish only is 2. So my whole fish circle should add up to 2. And it already does, so I have 0 left here. My cat circle, 2 and 1 is 3, so there's no more people with cats. Dog circle should total 13, so 2, 3, I already have 4. 9 is left. Okay. Then we need to find the number that goes on the outside. So if we add all these up, we get 13. And we had a total of 18 students, so 18 minus 13 gives me 5. All right, now we've got some questions below to answer about this. So excuse me, I'm going to have to go back and forth. So let's kind of look at the first 2 questions are similar. How many students only had a dog, only a cat, only a fish? Let's see. Only a dog was 9. Okay. Only a cat was 0, and only a fish was 0. Remember, when it says only, you're looking for places that do not overlap. Okay, how many students did not have any of these pets? Okay, so that was the number we found out here, so that was 5. Okay, so the next two questions are similar. How many students have had a dog or cat, but not a fish? And then this one says, how many have a dog and cat, but not a fish? So or means overlap. Okay, that's incorrect. Or means put together. So we're going to look at the dog and cat circles. So all of the dog and cat circles, and we're going to ignore the fish circles. So that leaves us with this one, and this one. So 9 plus 2 plus 0 is going to give me 11. And is where they overlap. Okay, so where dog and cat overlap is right here, 2 and 1. But it says not fish, so we're going to take away the bottom one because that's in the first fish circle, and we're just left with 2. How many students have only had one of these types of pets? Okay, so only one would be these parts right here, the dog only, cat only, and fish only. So 9 plus 0 plus 0. How many have had 2 or more of these types of pets? So 2 or more would be where they all overlap here. So 2 plus 1 would give us 4. This concludes the worksheet for section 2.2 and 2.3. You can now do the homework. Watch out for my email about the project coming up. And if you have any questions while doing the homework, please use the Ask My Instructor button.